Hello students, in this video we will discuss the remaining part of the spin orbit coupling as a part 2, and we already find this unpart of Hamiltonian for the spin orbit coupling. Now we will find the first order energy correction to the spin orbit coupling is as simple as expectations value of this Hamiltonian. Okay, now then E square divided by 8 phi epsilon naught and 1 over m square c square 1 over r cube expectations, and then the expectation of L is okay. Now we will find this two value and then put here, then we will get. Now the total angular momentum, the total angular momentum is the sum of the orbital angular momentum and the spin angular momentum, and the total angular momentum is represented by J is equal to L plus S as orbital and the spin angular momentum. Okay, now we squaring both side, then L into L plus 1 into L plus 1. Okay, and then J square is equal to L square plus S square, and then the 2L dot S. Okay, now we can find this value, then the L dot S is equal to this two term is transferred to this side is J square minus L square minus S square. Okay, and then divide by 2, then here. Okay, this is the value of the L dot S. Now we will find the eigenvalue of the L dot S, then we can take the expectation of this simply. This is 1 over half, and the J square, the value of the J is equal to J into J plus 1 under root into H cut, and the J square value is equal to J into J plus 1 and H cut square, and similarly for L and S is also here. Okay, and then we will take common the H cut square. We can write here H cut square, and then we write the value of this J into J plus 1 minus L into L plus 1 minus S into S plus 1. Okay, then for S is equal to 1 over half particle. This is the for the spin half particle. Okay, then the L dot S is equal to H cut square divided by 2 into J plus 1 minus L plus 1 and minus 3 divided by 4. This is equal to 3 divided by 4. Okay, this is so simple. Then we will find the expectations of 1 over r cube is equal to 1 over L and L plus 1 over half, then the L plus 1 and n cube a cube. Okay, now we will put this value into the above equations into this equation, then we can write these equations is E1 SO is equal to, this is the first order spin orbit coupling energy. Okay, is E square divided by 8 phi epsilon naught and 1 over m square c square or 1 over r cube, the expectations of 1 over r cube, and the expectation of the L dot S. Now we put the value of the the L dot is first is h cut square divided by 2, then the value of the j into j plus 1 minus L into L plus 1 minus 3 divided by 4 is the value of the L dot s, and divide by the value of the 1 over r cube expectations is this L into L plus half, then L plus 1 a cube n cube. Okay, now we simplify these equations, then for j is equal to L plus half, then we can write this equation is L j minus 1 over half. We already know this. Okay, then this is L. We put the value of L in here and here, then we can only simplify this term separately. Okay, this is j square, we can multiply this, and then j minus we put here the value of this is j minus 1 over half, and then j minus 1 over half plus 1. Okay, and divide by this value only is the j minus 1 over half and j minus 1 over half plus 1 over half, and then the value of j minus 1 over half plus 1. Okay, we can only simplify this term and we put again here. Okay, then this is cancelled to this, and we multiply this term to this term, then j square plus j, and then we can multiply this j out to all these terms, then we will get minus j square plus half j and minus j, and then plus half j and minus 1 over 4 and then plus 1 over 2. Okay, we multiply this term to the on these three terms, and then we will get. Okay, and divide by we can also write here minus 3 divided by 4 minus 3 divided by 4. Okay, and the above form. And now we simplify this is j into j minus 1 over half and j plus 1 over half. Okay, we simplify this and this term, then this is cancelled to this term is cancelled to this term, and only this 2 then is equal to, this is become j, and this is equal to minus 1 over half. We can simplify this is become minus 1 over half divided by this term j into j minus 1 over half and j plus 1 over half. This term is cancelled to this term, then only this term is remain is equal to 1 over j into j plus half. Okay, now we write these equations here, and this is equal to E1 spin orbit coupling is equal to, and now again we see these equations. These constants is represented in term of the E n square. Okay, these constants though, and then we can write these equations is E n square divided by mc square, and then the value of and also here look to this equation again. Only here this is, we here multiply the n and n. This is n4 is represented in term of the en square, and only the one n is remain above. Then we can write these equations. Okay, is n divided by this term j into j plus half. Okay, now the en here is equal to is now we can see again is the e square divided by 8 phi epsilon naught m into n4, and also with the a cubes. Okay, then this equation is obtained. So, and this is the first order energy of the spin orbit couplings. Okay, now we know the relativistic correction is equal to, we can find this in the previous videos, is equal to en square divided by a 2 mc square, here is minus, and 4n divided by j minus 3. Okay, we can find this term in the relativistic video. Okay, now the total fine structure correction is equal to, this is the fine structure first energy is equal to the E1R plus the spin orbit coupling ones. This is the relativistic one, and this is the spin orbiting coupling. Because the fine structure is consists of the two terms, the relativistic correction and the spin orbit correction. So this is the sum of the two correction is the spin orbit, the fine structure constants. Okay, then we can put the value of this 2 here, and then minus en square divided by 2 mc square and 4n divided by g minus 3, and then plus en square divided by mc square n divided by j into j plus 1 over half. We can put this value into these equations. Okay, now we simplify these equations, then we take common this, then we will get en square divided by 2 mc square, and then we can multiply this minus into this two term, then this become positive. Okay, and minus 4n divided by j, we take common this, and then plus we take this is common, and only and also here 2 we can divide and multiply. Now here the 2 is remain, 2 n divided by j and j plus 1 over half. Okay, then we can write these equations here. Now simplify these equations, then is en square divided by 2 mc square, and then the value of this is 3 plus 2n divided by j into j plus 1 over half, then minus 4n divided by j. Okay, now we can simplify these equations. Then the en square divided by 2mc square 3 plus, we take common this term as a whole, is 2n divided by j into j plus half. Okay, then here is only 1 minus 2, we take 2n and here is 4n, and then as equal to j plus half. Here we multiply and divide by 4 j plus half, then the j plus half is common, and only here is the j plus half is remains. Okay, then we can write these equations as 4mc square and 3 plus 2n divided by j and j plus half. Okay, and then 1, we can multiply this 2 into this 2 term, then 1 minus 2j and minus, and then minus 1. Okay, the 2 to cancel and minus this cancel to this term, and then we can write these equations is en square divided by 2mc square and 3 minus, here only this term is remain minus 2j can multiply to this is minus, and 4n and the j has become cancelled to this j divided by j plus half. Okay, this is the total Pine structure corrections. Okay, now we can edit this total fine structure correction to the Bohr energy. Then the total energy of the hydrogen atom is we can first write this is the total fine structure is added to the Bohr energy. This is a Bohr energy, we can represent it by this way. Okay, and then we can get the total energy for the hydrogen atom is Nj is equal to minus 13.6 electron volt divided by n square, and then 1 plus alpha square divided by n square, and n divided by j plus half minus 3 divided by 4. Okay, this is the total energy for the hydrogen atoms. Now this energy is depend upon on the value of the n and j, and also on the Pine structure constants. Okay, and the Pine structure is break the degeneracy in L, and for the given value of the n, then the different value of the L do not all carry the same energy. Okay, now we suppose for n is equal to 1, then the value of the L is equal to 0, because the L is equal to n minus 1, and the j value is equal to L plus half. Okay, now then the value of the j is equal to become halves. Okay, this is how this is equal to 0, this become halves. And then we can write for this energy is 1 and the j value is half. Okay, is equal to minus 13.6 electrons volt divide by 1 square and then the value of this alpha square divide by 1 square and then 1 and the value of j is equal to half plus half minus 3 divided by 4 into this. Then when we simplify this, then we will get 1 half is equal to minus 13.6 electrons volt and then 1 plus alpha square divided by 4. Okay, this is 1 and 1 minus 3 divided by 4 is 4 minus 3 divided by 4 is 1 over 4. They will alpha square divided by 4. This is the, for this state is the energy is this one. Okay, now we supposed for the another case here. Okay, then for n is equal to 2, then the value of L is equal to 0 and 1s. Okay, then first we for 0 and then and the value of the j is become half. Now for this the energy we can write directly as 2 half is equal to minus 13.6 divided by 4 and to 1 plus 3 alpha square divided by 16. Okay, now for a case for n is equal to 2 and the value of the L is equal to 1 and j is become 3 divided by 2. We write we use these equations. Okay, then the energy is 2 and 3 divided by 2 is we can write directly is minus 13.6 divided by 4 plus alpha square divided by 16. Okay, and this video is 3 times is greater than this video. Okay, here 3 divided by 16 and here is 1 over 16. So okay, now we look this video draw a figure, and here we can draw this video in here. These are the value of the for n is equal to 1, for n is equal to 2, and n is equal to 3 and n is equal to 4. We use these equations. L is equal to n minus 1 and j is equal to L plus half. Okay, for L is equal to 0, the j value is become halves, and then its energy is decreased by this term. Then the energy here from here to here. Okay, the energy is lower for n is equal to 1 states. Okay, this is this energy. Okay, and then for n is equal to 2, the L value for L is equal to 0 is this states, and for L is equal to 1 have 2 states too, is j half and j 3 divided by 2. Okay, this is the energy for the 3 divided by 2, the value of j. Okay, now for n is equal to 3, then the value of the L is 3, 0, 1, 2. For 0 is j half only, and for L is equal to 1 have also 2 states is j half and j 3 divided by 2. And now for L is equal to 2, there are 2 states too, 3 divided by 2 and 5 divided by 2. Okay, and similarly for n is equal to 4 have some other state is added to this. Okay.